It's complicated to be a human being in the 21st century. I often feel anxious, unsatisfied, and overwhelmed with responsibility. In such times I long for a return to the lifestyle and environment of my ancestors. Probably the grass is greener on the other side, and living that more primitive existence would have me pining for some greater purpose and adventure. But at the very least, life would be simpler. The tasks and virtues that I expect of myself and that others expect of me would be factorable and understandable. I would know what to do. I could keep the demons of uncertainty and insufficiency at bay so long as I leaned into the tasks and values of my tribe. Hell, I might even excel. I might become a good hunter, a fine husband, an accomplished farmer and warrior. I might know myself well and understand my role in the world. I might age into a position of veneration, known and revered in my community. But how does that scale to the modern landscape, with its decisions and consequences, and multitudinous sources of possibility and disappointment? I must establish goals to pursue. Are they the right goals? I must avoid obstacles and seize upon opportunities. Which is which? How shall I proceed? This is the condition of the individual in our society, a crisis of meaning and self-integration. No wonder we're all fucked up. In Episode 8, I discussed the topic of qualitative experiences with regard to value. In that episode, I said, there is a dimension along which qualitative experiences, along which qualia can vary widely. It's easy enough to make a list of our favorite and least favorite kinds of experiences, and at the foundation of those kinds of experiences are implicit or explicit goals. If I list some unpleasant qualia, there are those of a perceptual nature, the sensations of pain, which can be experienced to varying degrees of intensity, and flavors like burning or dull ache or sharp sting. These sensory kinds of pain must occur in association with topographical maps related to body representation. And notably, pains like these can be especially salient and specific. Related to pain are sensations like pernicious itchiness. In all of these cases, the capability to prevent or relieve the suffering is such that one would be strongly compelled to do so. I went on in that episode to consider different kinds of pain and suffering and to contrast them with different flavors of pleasure and satisfaction. I described how built-in motivational systems utilize the valence of qualia to manipulate us into acting in the interest of our evolved nature, the implicit goals that underlie our behaviors. In this episode, I would like to go in a somewhat different and more speculative direction. If the purpose of putting our conscious minds through states of suffering is to cause us to behave in certain ways, implying of course that the conscious mind has causal power, at least in part, over behavior, then I am very interested to know how such states are produced in the thalamocortical system. I have many times made the claim that conscious contents are meaningful, and according to my theoretical framework, the TICL, they are meaningful because the subsystems which give rise to the contents occur on an ordered architecture as part of an overall system. From the point of view of the system, the dynamics of the subsystems are specific and meaningful. This might explain why we see a blue object over here, and here something low-pitched over there, and so on. The sounds and sights are represented in the brain on topographical maps that produce the sense of space and time within which the contents appear and change and disappear. But given this idea, it is not at all obvious how something could occur in the landscape of consciousness having a negative valence. How does the brain produce the meaning pain? I am not referring to the concept of pain or the syntactic label pain, but the actual quality of suffering, the semantic phenomenon that occurs in each of us under such conditions. Suppose you were an engineer producing advanced artificially intelligent beings. Allow that neuroscience has advanced to the point that we understand the mechanisms which produce conscious experiences. Engineers can therefore construct conscious beings using non-biological hardware by arranging it into causal structures in a brain-like architecture. The hardware is ordered so as to produce phenomenal contents that exist and have meaning from the point of view of the AI being. Topographical maps and such enable the AI being to appreciate space and time and have a body representation and all the rest. Now suppose that you wanted to hurt that AI being. You want to cause that being to suffer pain in accordance with certain kinds of insults to its body, for example. Clearly, we see that such pains are adaptive in animals like us because the implicit goal of avoiding and remedying injury is critical to our survival. Likewise, we don't want our expensive AI robot to merrily go about doing anything that damages it. The answer must not be some algorithm or set of algorithms that control the behavior of the AI being. That is cheating. After all, this is a conscious and willful being we are engineering, not an automaton. How can we cause it to experience pain? We know pain from the phenomenal side. We know what it is like. Furthermore, we know some of the peripheral and central nervous system structures involved. But keep in mind, pain receptors, just like any other receptors on the body, are just sending action potentials up to target networks in the brain. They are not mechanistically different than any other receptor systems. They are not special. So the important mechanistic effects that underlie painful experiences must be occurring in the brain. My curiosity, then, is about what happens in the brain networks that causes emergent phenomenal pain. Back in the episode on value, I cataloged some varieties of human suffering, which is to say, qualia which exhibit a negative valence. We can start with the bodily pains that attend illness or injury of one kind or another: aching pain, stinging pain, burning pain, freezing pain, and so on. Generally, such sensations are experienced as occurring on the body map at some particular location. Despite the fact that all of these sensations are necessarily occurring somewhere in the cerebral cortex, they are actually experienced as occurring in space, out on the extremity which has recently sustained some insult, for example. Psychological distresses of different types seem at least analogous to the bodily pains. These modes of suffering often have an emotional dimension: annoyance, frustration, fear, grief, melancholy, shame, anxiety. I could further divide the object of these feelings into self and other. Of course, the feeling itself is occurring in the conscious mind of the individual having the experience, but we can see that annoyance and frustration might be directed at some obstacle, human or otherwise. I've seen children become enraged and commence to yell and assault a perfectly inanimate object for its failure to comply with a child's project. In such a moment of rage, the child even assigns agency to the object of her wrath and insists that the thing is acting purposely to thwart her. If this observation is at all generalizable, anger seems to be the emotional state that makes one hostile and prepared for violence, presumably in order to overcome certain kinds of threatening obstacles to our goals. So these feelings of suffering have an external object. In contrast, shame and depression are in a sense self-directed feelings. The object of the antagonism is the self, or perhaps some aspect of the self. The obstacle is internal. Noxious stimuli activate receptors on the skin and deep tissues called nociceptors. There are thermal nociceptors, mechanical nociceptors, and polymodal nociceptors, which are activated by high-density mechanical, thermal, or chemical stimuli. Immediate sharp pain is carried by myelinated axons, which carry fast signals to the central nervous system. A second, slower aspect of pain coming from polymodal nociceptors results from slower signaling that is carried by non-myelinated C fibers. The major direct or indirect targets of these signals are in the thalamus, which relays them to the somatosensory cortex and association cortices. Do qualia of a negative valence have something mechanistic in common? Perceptual qualia tend to be emergent from network activities of a topographical arrangement. Second and third order qualia, such as thinking about or noticing first order qualia, would be expected to occur in a nested hierarchy of such networks. The question is, how do pain and other forms of suffering emerge in such structures? Let's start by considering a common pain, like that which occurs when you stub your toe. The pain is of a throbbing, aching nature, localized to the toe on the body representation. The sensation of sudden force and sharp pain occurs a moment or two before the aching pain because the neurons that carry polymodal pain sensations from the peripheral nervous system are not insulated with myelin the way that other peripheral neurons are. In theory, a subsystem quickly emerges with inclusion of the somatosensory network corresponding to the appropriate toe. The phenomenal result is a strong sensation. This is likely to be accompanied by phenomenal surprise. In short, the system should produce subsystems of a nested architecture such that the surprise is about what just happened at the toe, along with the attendant tripping over and probably reflexively catching yourself and so on. The aching pain then enters the picture. I'd like to know how phenomenal pain could be produced by any network activity. Two independent possibilities suggest themselves to me within this framework of thinking. One, Pain occurs on its own topographical map, the way that sound or vision or bodily sensation does. Under this hypothesis, pain is an independent sensation from other perceptions of the body. This is analogous to being hit with a stick and hearing the loud smack of the strike. There are two independent perceptual events, the sensation of the strike on the body surface and the sound that is produced when the stick breaks across it. A deaf person would get the former, but not the latter. The resulting pain is undiminished by deafness. The second hypothesis is this. Pain occurs due to a particular change in the network activity that produces the subsystems corresponding to bodily sensation of the toe. This change in the subsystem's operation is experienced as having a negative valence. It not only feels, but it feels bad. Since the signals coming from nociceptors target at least in part the same somatosensory locations as non-nociceptive signals, in this case the area representing the toe, my second hypothesis is more likely. In the Principles of Neural Science, edited by Eric Kandel, James Schwartz, and Thomas Jessell, the gate control theory is introduced in brief. They write, quote, "Pain is not simply a direct product of the activity of nociceptive afferent fibers, but is regulated by activity in other myelinated afferents that are not directly concerned with the transmission of nociceptive information. The idea that pain results from the balance of activity in nociceptive and non-nociceptive afferents was formulated in the 1960s and was called the gate control theory. This theory incorporates several key observations. First, neurons of lamina 5 and possibly lamina 1 receive convergent excitatory input from both non-nociceptive A beta fibers and nociceptive A delta and C fibers. Second, large diameter A beta fibers inhibit the firing of neurons in lamina 5 by activating inhibitory interneurons in lamina 2. Third, the A delta and C fibers excite lamina 5 neurons but also inhibit the firing of inhibitory interneurons in lamina 2, which are activated by the A beta fibers. Simply put, non-nociceptive afferents close and nociceptive afferents open the gate to the central transmission of noxious input." Unquote. What this implies is that the mapping of body sensations like touch and light pressure is coordinated with and in common cortical space as body sensations of pain. It is the nature of the action potential signaling in that somatosensory network that is altered by nociceptive input. Think about music. A set of notes played together such that it sounds good to us is known as a chord. A set of notes that do not sound good played together sounds discordant. We prefer the former and dislike the sound of discordance. Most importantly, the notes that sound good together do so for a reason. There is nothing arbitrary about it. A note has a particular frequency. For example, the open third string on a guitar plays a G note at 196 Hz. If we advance 12 frets down the neck of the guitar and hold the third string there, we will hear exactly twice the frequency, another G note at 392 Hz. This is an octave. The ratio is simply 2:1. What makes different notes sound good together? The answer is particular ratios between their frequencies. A fifth is 3:2. A major third is 5:4. For a G chord, the root note is G. The fifth is B, and the major third is D. Thus, the ratios among different notes make the difference in the quality of what we hear, whether or not it sounds good. Dissonant ratios produce a sense of tension in the listener. I'm not really a musician, and I certainly am not a music theoretician, but to me this analysis provides an intriguing point of leverage between mathematics and phenomenology. The auditory system is interesting because the membrane in the inner ear is a kind of instrument along which there are continuous receptors. Because of this, we can appreciate the frequencies that are captured all along that instrument. If this information is passed to the thalamus and auditory cortex in such a way that the frequencies of sound lead to action potential frequencies that carry the same ratios, then it might be the ratios themselves which lead to pleasant or unpleasant auditory experiences. In line with the TICL framework, a scenario is suggested in which a 3-note G chord is heard. There might be 3 separate subsystems that occur in the auditory and associated cortex, one corresponding to each of the notes, G, B, and D. In addition, these 3 subsystems might be nested within a 4th, larger subsystem which encompasses them. If something like this is occurring, the individual contents of consciousness arising from each of these subsystems form a geometric arrangement that is appreciable as pleasant to hear because the relationships among them are simple mathematical ratios. Complex mathematical ratios, which cannot be factored to simpler ones, might be confusing and unpleasant. This could explain the tension that is felt when discordant notes are played. In the case of 3 discordant notes played together, 3 independent subsystems would occur in the cortex, but a 4th greater subsystem encompassing the first 3 would be unwieldy and confusing. From the point of view of the system, this input is disturbing and unpleasant. Let us now return to our stubbed toe. A sudden force impinging upon the receptors of the toe could lead to the formation of a subsystem in the somatosensory cortical area associated with the toe, producing a strong sensation of sharp force on that part of the body representation. In the context of the larger body representation, this new event is a specific note of discordance within an otherwise harmonious background. In accordance with the gate control theory, if the gate is open, it allows the discordance corresponding to the toe's somatosensory network to ring out and disturb the symphony of our nested body representation. The ratios between different firing behaviors in adjacent baseline networks are simple and understandable. The new subsystemic firing that results from the stubbed toe stimulus is mathematically unfactorable and painful. I recognize that this speculation is incomplete and likely incorrect, but it seems to me that something which has its foundation in physics and is describable in mathematical terms must account for the existence of pain. We know that action potentials are the means by which signals from the body get into the thalamocortical system. Frequency of action potentials is a major communication method between neurons. Their signals are not merely binary, fire or do not fire, but made analog in that the number of action potentials fired increases their influence upon downstream neurons. Networks of neuronal elements, each firing in this way, account one way or another for the contents of consciousness. But how about the ratios of firing frequencies within one network and another? Might that relation be realized by the larger system in the form of meaningful conscious events? What about psychological modes of suffering? Annoyance, frustration, fear, grief, melancholy, shame, anxiety. In accordance with the hypothesis I have described, an implicit or explicit goal is discordant with a set of realized stimuli. Frustration emerges when behavior does not agree with its expected or desired outcome. Nested under a common subsystem, the behavior and the outcome do not factor into a simple, understandable mathematical ratio. Instead, like the discordant combination of notes on the guitar, the result is a sense of tension and distress.